Hi, welcome to your first Algebra 1 quiz review of this semester. So we're working on operations with radicals and unit conversions. The first portion, the operation with radicals, where there's not a lot of calculator, so make sure you're working this without a calculator. So number 1 says simplify 112. So I'm going to break that down into 2 and 56. I know 2 is prime, so I'm going to circle it and put it in my radical. Now I got to break down 56. Since it ends in 6, which is an even number, I know 2 goes into it again. So I get 2 and 28. I'm going to circle my 2 and bring it up under the radical. 28 I know is 4 and 7. I got to break down 4 to 2 and 2, which are both prime. I'm going to bring them up here under my radical, and then I have 7, which is prime. So now that I have my 112 broken down to prime numbers, I'm going to look for my pairs. Well, I have a pair of 2's here and another pair of 2's. So this pair of 2 comes outside and becomes 1, 2. This pair of 2 also comes outside and becomes 1, 2. And then the poor 7 has to stay home under the radical. My last step is to multiply these outside numbers. So 2 times 2 is 4. So I get 4 radical 7 as my answer. Okay, let's look at number 2. I have 63. Well, that looks like 3 goes into it. So we're going to have 3 and 21. 3 is prime, so I'm going to circle it and put it under my radical. 21 is 3 and 7. I'm going to circle 3 and put it in my radical, and 7. Again, I'm looking for my pairs. Since I have a pair of 3's, I'm going to circle them and they come out as 1, 3. And then I have my radical 7 that has to stay home by himself. So I get 3 radical 7. Okay, number 3 is a little different because it has an 8 already sitting out there. I'm going to work it the same way, but whatever I pull out from under the radical also has to be multiplied by that 8. It's going to break down the 20 to 2 and 10. So I like to rewrite this as 8, and then there my radical. So I'm going to put my 2 under the radical. Then my 10 breaks down to 2 and 5. So again, I'm going to circle my 2 and put it on the radical. And then I'm going to circle my 5 and put it on the radical because they're both prime numbers. So I'm going to bring down my 8. I'm going to look for my pairs. I have a pair of 2's. So it comes down outside of the radical. And then the 5 gets to stay home under the radical. Remember, I'm going to multiply these outside numbers. So 8 and 2 gives me 16. Radical 5. Okay, number 4, we're going to work exact same way. Even though that's a negative 6 out there, it's not really going to change how we approach it. So 32 I'm going to do is 4 and 8. 4, I got to break down some more to 2 and 2. Going to bring my 2's up here. 8, I got to break down to 2 and 4. Bring that 2 up and bring this 4 and break it down to 2 and 2. I like to check. I have 1, 2, 3, 4, 5, 2. So 1, 2, 3, 4, 5, 2. So far I'm good. Now I'm going to look for my pairs. I have a pair of 2's and I have another pair of 2's. So I have this negative 6 sitting out. We're going to bring down this pair and become 1, 2. Going to bring down this pair and becomes another 2. And then we have this 2 who has to stay home. So negative 6 times 2 is negative 12. Negative 12 times 2 is negative 24. So we get negative 24 root 2. Okay, number 5. Same idea. We're still just simplifying our radicals. So 72, I'm going to break down to 9 and 8. Got to break down my 9 to 3 and 3, which are both prime. So I'm going to circle them and put them under the radical. 8, I got to break down to 2 and 4. 2 is prime, so it goes under the radical. Got to break down my 4, which is 2 and 2. Okay, now I have everything to primes, so I'm going to circle my pair. I have a pair of 3s, and I have a pair of 2s. So don't forget your 7. Then we're going to bring down our 3. We're going to bring down our 2, and then we have this 2 sitting at home. So 7 times 3 is 21. 21 times 2 is 42. Radical 2. Remember, we're just multiplying those outside numbers. Okay, so now we're kind of switching ideas on number 6. Number 6 is subtracting radicals. And for us to subtract radicals, the radicand, the number underneath, have to be the same. Well, this is square root of 5 and square root of 20. They are not the same, so I can't subtract them. So I got to try by simplifying them. So I have negative square root of 5. I can't break down that 5 at all, but I can break down this 20. 20 becomes 4 and 5. 4 becomes 2 and 2. So there's my primes. So I'm going to rewrite this as negative square root of 5 minus the square root of 2 times 2 times 5. Again, I can't do anything with this negative square root of 5 right now. Minus, I have a pair of 2s, so those 2s are going to come outside of my radical, but we still have a square root of 5. Notice the radicand, or the number under the radical, is now the same. Once they're the same, you have like terms. So now we can look at these outside numbers and we can combine like terms. So negative 1 and negative 2, they're like terms. We're going to get negative 3, and then we're going to keep the radical of 5. So my answer is negative 3 radical 5. So remember, to add and subtract, you have to have like radicals. Let's do another one like that. That was kind of difficult. Okay, let's look at 7. Okay, so I have radical 5 and radical 45. They are not alike, so I can't just add them. Well, I can't break down 3 radical 5, but I can break down 45. 45 is 9 and 5, and 9 is 3 and 3. So we have 3 radical 5 plus 3 radical, and then I have 3 times 3 times 5. My pair of 3 is going to come out, so I have 3 radical 5 plus 9 radical 5. Now the radicals are the same. So since the radicands are the same, I can add the outsides. So 3 plus 9, because those are the same, is 12. And then we're going to keep our radical 5. We have like terms now. Okay, look at number 8. It says 2 radical 5 minus 3 radical 5. Well, they're the same. I have a radical 5 on both of them, so I can just combine my 2 minus 3. 2 minus 3 is negative 1, and then we're going to keep our radical 5. Okay, here we go. Number 9. Number 9 is multiplying radicals. When we multiply radicals, I like to say you multiply inside times inside and outside times outside. Then simplify. Okay, so let's talk about this. What is my outside numbers? I have a negative 5, and then there's an assumed 1 here. So negative 5 times 1 is negative 5. Square root. Now we're going to multiply our inside. I'm actually not going to multiply it. I'm going to leave it as 6 times 10. And then we're going to break them down. So 6 becomes 2 and 3, both prime. 10 becomes 2 and 5, both prime. So now I'm going to rewrite this. We have negative 5 radical 2 times 3 times 2 times 5. To come out of the radical, we need a pair, where I have a pair of 2's. That's the only pair I have. Now don't forget, you have to multiply that by your -5. So I have -5 times 2, and still inside are 3 and 5, and I'm going to multiply those. So then I get -10 radical 15. Okay, look at number 10. Same idea, outside times outside and inside times inside. Well, my two outsides are -3 and -3. So -3 times -3 is a +9. Then I'm going to do inside times inside, so 6 times 3. I'm going to break down my 6. It's 2 and 3, which are both prime, and I can't forget that prime one sitting there. So now we have 9 radical 2 times 3 times 3. I have a pair of 3, so they're going to come outside. So we have 9 times 3 radical 2, which gives us 27 radical 2. Okay, so now we're doing the same idea on number 11, but our numbers are getting a little bit bigger, but that's okay. The process isn't going to change. So we're going to still multiply outside times outside. So 3 times -2 gives me a -6. And then I'm going to multiply inside times the inside, and I get 8 times 20. Now I have to break them down. So 8 breaks down to 2 and 4, which breaks down to 2 and 2. 20 breaks down to 2 and 10, and then 2 and 5. Now you could have gone a different way with 20, but you'll end up with the same answer. So I have -6 square root, and then I'm going to write everything that I've circled. Now I need pairs, so I have a pair of 2, another pair of 2s. So remember, I'm going to multiply those when they come out. So this becomes -6 times 2, which is -12 times 2 is -24. And then I'm going to multiply what's left inside, which is 10. So we have -4 radical 10. Whew. Okay, number 12. Now on number 12, we've got parentheses and we have to distribute. So we're still using our properties, but now we're distributing. So we're going to do a square root of 3 times square root of 3. So it's still inside times inside and outside times outside. So this gives me 3 times 3 is 9, plus, now I got to do square root of 3 times 3. Now this 3 is outside. So this is 3 radical 3. Well, the square root of 9 is 3, so we get 3 plus 3 radical 3. I can't go any further because those are not like terms. So I am done right there. Let's do another one like that because that one's kind of hard. Look at 13. Okay, so square root of 2 is on the inside. 2 is on the outside and square root of 2 is on the inside. So we're going to distribute. So I'm going to write a 1 here. So I have 2 radical 2 times 2 plus 2 radical 2 times 5. Well, I already have my pair of 2's, so they come out. So 2 times 2 is 4. There's nothing that comes out here, so I'm just going to leave it as 2 square root of 10. I can't combine like terms because they're not like terms. So there's my final answer. If you haven't done so, I would suggest that you pause the video and try one on your own, and then come back and check yourself. Okay, number 14, same idea. I'm going to multiply, I'm going to distribute this. So I'm going to multiply the outside, so 1 and -2, so -2. And then we have 6 times 10 plus 1 and 1 is 1, and the square root of 6 times 3, because I'm distributing that, and they're both under the radical. So now I got to break down my numbers. So 6 breaks down to 2 and 3. 10 breaks down to 2 and 5. So this gives me -2 radical 2 times 3 times 2 times 5. Break down this 6 is 2 and 3. And that's a 3. So plus 2 times 3 times 3. Same concept we've been looking for. I'm looking for a pair, so I have a pair of 2's. I'm going to multiply that, so I get -4, and then I'm going to multiply the 5 and 3, so 15. Over here I have a pair of 3's that are come out, so 3 radical 2. The number under the radicals are not the same, so there's nothing else I can do, so that's my final answer. Okay, we're practicing more and more like this. So 15. Okay, so number 15 and 16 have a radical with a variable under there. If your teacher didn't talk about those, that's okay. We're not going to put them on the quiz, but I just want to show them to you just in case. So I've square root of 3 times square root of 5n. They're both inside the radical, so that becomes 3 times 5 times n plus square root of 3 times 5. Now 5 is outside the radical, so this becomes 5 times the square root of 3. Well, nothing can be simplified here, and I have no pair, so I can just multiply that all, and I get 15n plus 5 radical 3. So there's my final answer because there's nothing I can do to simplify it. Okay, same idea on 16. Okay, we're going to distribute this square root of 15n times square root of 3. They are both inside the radical, so I'm going to write them as 1. So 15 times 3 times n plus, now I'm going to do square root of 15n times 3 square root of 5. Notice this 3 is outside of the radical, so it's going to stay outside. And then we have 15 times 5 times n. So now I got to break down my 15. That becomes 3 and 5. So 3, 5, and 3. So I'm going to rewrite this as 3 times 5 times 3 times n. Plus, over here I'm going to break it down as 5 and 3. So plus 3 radical 5 times 3 times 5 times n. Again, I'm looking for pairs. So on the first one I have a pair of 3's. And they're going to come out. So I get 3 radical 5n. On the second one, the 5's, I have a pair of 5's. Now when I take those out, I have to remember to multiply them by that 3. So that gives me 15 radical 3n. Notice this is a 5n and this is a 3n, so I can't combine. So then that is my final answer. Wow, guys, y'all are doing a great job. Keep it up. So 17, we're getting to the harder multiplication problems. And the reason they're harder is because now we have to multiply two things. So what we're going to do is we're going to have to distribute twice. So this first time I'm going to do square root of 5 times square root of 5. So that gives me square root of 5 times 5. And then I'm going to distribute that square root of 5 times this 5. So now this 5 is outside of the radical. So then this is going to be plus 5 radical 5. Now we got to do the same thing. This time we have to distribute the 4. So we're going to do 4 times square root of 5. Remember, this 4 is on the outside and the square root of 5 is on the inside, so this just becomes 4 square root of 5. And then the 4's got to go with 5. They're both outside. 4 times 5 is 20. Now we're going to simplify and combine like terms. So square root of 5 and square root of 5 times 5 gives me a pair, so it comes out. So I have 5. Notice I have some like terms right here. I have a square root of 5 and a square root of 5. So I can add those. Remember, you add the outside, so 9 square root of 5. And then I have this plus 20. Now I can combine the 20 and the 5. So I get 25 plus 9 radical 5. Okay, let's try that again with 18. So we're going to start by distributing this negative 3. So negative 3 times negative 4 gives me a positive 12. Negative 3 times 5 radical 5. So negative 3 is outside and 5 is outside. So I get negative 15 radical 5. Now I got to distribute my next set. So I'm going to do 5 square root of 5 times negative 4, which gives me negative 20 radical 5. And last one, outside times outside, so 5 times 5 is 25, and then we're going to multiply the insides. There's a lot going on there, so we're going to take it step by step. So there's nothing I can do with this 12, so I'm just going to bring it down. Notice I have like terms of a negative 15 square root of 5 and a negative 20 square root of 5. So that becomes a negative 35 square root of 5. This right here, this 5 comes out. And I'm going to multiply it by the 25, which gives me 125. And now I can combine some like terms. So I have 12 and 125, so I get 137 minus 35 radical 5. And that is my final answer. Okay, number 19. What does that little 2 up there mean? That actually means we have 2 sets of those parentheses, so I'm going to write them twice. So I have 3 radical 2 plus 5 radical 7 times 3 radical 2 plus 5 radical 7. Now we're going to do exactly what we just did, same process. We're going to distribute and multiply. So 3 square root of 2 times 3 square root of 2 gives me 9 square root of 2 times 2. Then 3 square root of 2 times 5 square root of 7 gives me 15, and then 2 and 7. Now I'm going to distribute the next. So I have 5 square root of 7 times 3 square root of 2 gives me 15, 2 times 7 again. And then distribute to the last, and I get 25 square root 7 times 7. Okay, and so in my next step, notice I have a pair of 2s, so they're going to come out and multiply by the 9, I get 18. Plus, there's nothing that simplifies with 2 and 7, so this is 15 square root of 14 plus 15. Again, nothing simplifies with 2 and 7, square root of 14. Here my 7's come out, so I'm going to take that 7 and I'm going to multiply it by the 25. And I get 175. My last step is to combine any like terms. So 15 square root of 4 and 14 and 15 square root of 14 gives me 30 square root of 14. And then I can add 18 and 175 and I get 193. So I get 193 plus 30 square root of 14. Oop, I took a little too much room for that one. Sorry. Okay, let's try. I want you to try 20, pause the video, and then come back and check yourself. Okay, so again, this 2 out here means we have 2 groups of it. So I have square root of 2 plus 4 square root of 5 twice. So I'm going to distribute. So I'm going to do it over here. So I have square root of 2 times 2. Plus 4 square root of 10 plus 4 square root of 10 plus 16 times 5 times 5. So this becomes 2 plus 8 square root of 10. And then this 5's are going to come out, so I'm going to multiply it by 16. So I get 80. So then I get 82 plus 8 radical 10. Oops, sorry, I did all that and I was off screen. I'm so sorry. There you go. Okay, whew, we made it through multiplying. Okay, so now we're going to do some division of radicals. So with division of radicals, I always say the first thing you should do is to look to see if your denominator is a perfect square. Well, 100 is a perfect square. 100 is 10 times 10, so the square root of 100 is 10. The numerator, 8, is not a perfect square, so I'm going to have to break down 8. So that becomes 2 and 4, and then 2 and 2. So this becomes square root of 2 times 2 times 2. Just like we've done, I'm looking for a pair. I have a pair, so they come outside the radical. This other 2 has to stay home, and it's all over 10. Notice this 2 and this 10 are both outside the radical, so then I can simplify them. So 2 over 10 simplifies to 1 over 5, and then we have the radical 2. So we get radical 2 over 5 as our final answer. Okay, 22. Again, I look at my denominator. It is a perfect square. So we know the square root of 64 is 8. So now I no longer have a radical in the denominator. So now I'm going to break down my 12. So I can do 2 and 6. And then 6 is 2 and 3. I have a pair of 2, so they're going to come outside. So I get 4 radical 3 over 8. Again, I can simplify the numbers on the outside of the radical. So 4 and 8 simplify to 1/2. So I have square root of 3 over 2. Oh no, 23. Our denominator is not a perfect square. So what I'm going to do is I'm going to rewrite this as one radical. So this becomes the radical of 15 divided by 3. Okay, well I can do that division. 15 divided by 3 is just 5. Oh, so my answer is just the square root of 5. Whew, I like that one. Okay. 24. Look at your denominator. It's a perfect square, so it becomes 2. Look at your numerator. Well, it's also a perfect square, so it's just 3. So our answer is just 3 over 2. Yay! Okay, so that is our end with radicals. The next part is going to be our problems with dimensional analysis or unit conversions. This is the part you do get a calculator for. So if you want to go grab your calculator, you can, so you feel ready for it. And we're going to start. So a rectangle has a length of 9 meters and a width of 1,250 centimeters. So 9 meters, 1,250 centimeters. What is the perimeter in centimeters? Well, so Miss Campbell's way off the screen on this one, sorry. The problem is we want the answer in centimeters, but I have meters right here. So I have to convert those meters to centimeters. So that's our first step. So we know 9 meters. I'm going to multiply. Well, I know in 1 meter, there's 100 centimeters. Now my meter units cancel. I have centimeters like I want, so I'm going to multiply the top, so I get 900 centimeters. So I can rewrite this as 900 centimeters. But I'm not done yet because it asked me to find the perimeter. So to find the perimeter, we have to add up all the sides. Well, this side is 1250, you know this side is 1250. If this side is 900, you know this side is 900. So now to find the perimeter, I'm going to add 1250 plus 900 plus 1250 plus 900. And you can put all that in your calculator. And I get 4,300 centimeters. So my perimeter is 4,300 centimeters. Okay, number 26. Julia swam 2,000 meters in 21 minutes and 43 seconds. if each lap is 400 meters long, what is our time in seconds per lap? So we want the answer in seconds per lap. So let's talk about it. Is all of my time in seconds? Nope, we have this part, this 43, but I got to convert this 21 minutes to seconds. So that's my first step. 21 minutes, I have to convert to seconds. Well, I know there's a relationship that 1 minute equals 60 seconds. My minutes cancel, so I have the units of seconds like I want. So I'm going to multiply the top. So 21 times 60 is 1,260 seconds. But I can't forget, I have to add that 43 seconds to it. So that becomes a total of 1303 seconds. So now we have 1303 seconds. Okay, great. That was for 2,000 meters, but I don't want my answer in meters. I want my answer in laps. But right here it says 1 lap equals 400 meters. So I can convert my 2,000 meters into laps. So I'm going to put meters on the bottom. So 400 meters equals 1 lap. I'm going to cancel out. So I have 2,000 divided by 400, and I get 5 laps. So it takes Julia 1,003 seconds to swim 5 laps, but I don't want it per 1 lap. I want it per 5 laps, I want it per 1. So I'm going to divide that, and I get 260.6 seconds per lap. Oop, I went off the screen. I divided 1303 divided by 5, and that's how I got the 260.6. Okay, 27. It says the distance from the trailers to the bathroom is 6,547 inches. What is that in yards? So we're trying to convert from inches to yards. Well, there's not a straight conversion between inches and yards, but I know there's 12 inches in 1 foot. So now I have the unit of feet. But I don't want feet, I want yards, so I know 3 feet equal 1 yard. My feet. Now I have the correct units of yards, so I'm just going to multiply my tops. So I get 6,547 divided by, I'm going to multiply my bottoms, 36. So 6,547 divided by 36 gives me 181.9 yards. Oh, we're almost there, guys. Here we go, our last one. Stephen averages 3 minutes and 17 seconds to run 1 lap around the track. At that speed, how many minutes will it take Stephen to run 8 laps? How many minutes? So we're looking for minutes. So I want all of my answers in minutes. So we want